Hello everyone, this is Pankaj. I welcome you all to new day, new question series. So once again we have one more question here as you can see on the screen. The question is basically saying we have one bed. This is the bed we have of mass m slides without friction on the wall of a vertical circular hoop. So this is that bed which is basically moving in the downward direction and there is no friction present here, like your value of friction is 0. It means we can apply the conservation of mechanical energy because work done by non-conservative forces will be 0. Now radius they are mentioning of the hoop as a r. Now one more thing, the bed moves under the combined action of gravity as well as the spring force, and the spring is attached to the bottom of the hook. The equilibrium length, it means the natural length of the spring is r. Now bed is basically released, it means its initial speed will be 0 from the top of the hook. Now when it will come to the downward direction and the length of the spring becomes r, that is the natural length, at that time we want to find the speed of that bed. Okay, so let me draw the diagram first and once again I will explain the same question. So this is the diagram which I have already drawn because it will take more time if I try to draw here. So what we have in this question, listen everyone, this is the bed we have, it is coming in the downward direction. Okay, no problem. Now when it is coming in the downward direction, the reasons are two forces. One reason is because of force of gravity and one reason is because your spring force. Now when it is coming in the downward direction, they have said that initially the spring is extended up to length 2r and its natural length is r. It means the extension of the spring is from r to 2r. So change in length of spring, that is delta x or x, it will be equal to r. Okay, we can write down that our extension x will be equals to r. After this, one more thing. Now many students have one misconception while solving this question, and that misconception is while this bed is coming in the downward direction, this should be its final position where spring will have the natural length r. Let me draw the diagram so that I can explain you. Like this is our spring whose half length is basically already r because complete this length is 2r now, so half will be your r. Okay, this is our reference line, that is this diameter, this one. Okay, and as per the misconception what many students do, they take this position, I mean this position as the final position of the bed when it comes in the downward direction and spring comes to your natural length. So suppose if some student is solving the same question by taking this position as the final position of the spring and saying that this length will be the natural length having value r, then what is wrong here is this is our kind of radius now, so this length will also become equal to r. If this length is r, this length is r, how can we say that this one will be r? Because this angle is 90 degree and according to Pythagoras theorem this one is your hypotenuse, which is the longest side of the triangle. So we cannot take this length as a r. We will have to move our bed somewhat in the downward direction, which we have already done here as you can see. This is the final position of the spring I have taken. Now this is the radius r, this is the natural length of the spring r. Now if this is r, this one is also r, by the symmetry we can say that this length will also equals to r, and this will be your equilateral triangle. And if this one is your equilateral triangle, not by symmetry, we know that this is the radius of circle now. If this one is the radius of circle, of course its length will be r. Now this one is r, this one is r, and this one is r. All are seems like equal side, so it will be your equilateral triangle. That's why I have taken this as a 60 degree. This one will be 60, this one will be 60, this one will also be 60. Okay, now one more thing, listen. Entire length is r. If I draw one perpendicular from here, it will act as a median. It means it will divide this r into two equal sides. Or if you are not doing anything like that, let's go with the concept of factor. If I am saying this is my triangle, this one is r, this one is r, this one is 90, this one is basically 60. So if I try to resolve this side, which means I am saying this one, its component here will be r cos 60. Cos 60 means 1 by 2, which will be ultimately r by 2. That's why you can see that here I have taken r by 2. Complete length, how much we have? R. This length is r by 2, so of course remaining will also be the r by 2. And last thing, this will be the point like where bed will finally come and your spring will comes to the natural length r, and this point I will assume as my reference point. Above it I will measure the height for the gravitational potential energy. Now this is the basically what we can say complete question, or like the easiest solution of the question we have, because this question is not that much tough. The only thing which is tough in this question is to understand the question, because once you understand the question, once you have drawn the diagram of this question, there will be nothing which will stop you from solving this question, because after this step only thing which we have to do is to apply the conservation of mechanical energy. So let's applying conservation of mechanical energy, that is kinetic energy plus potential energy. Initial is equals to kinetic energy plus potential energy. Kinetic energy plus potential energy final. Okay, now as we can see, object is starting from rest, so initial kinetic energy will be 0. Potential energy initial will be because of gravity, that is mgh, as well as because of the spring, that is half kx square. Final kinetic energy we want to find, that is half mv square. Final potential energy will also be 0 because spring is coming to its natural length, and this line, this is our reference line. Here basically our gravitational potential energy will also become 0. Okay, so in order to remove the 2, I am basically multiplying the entire equation by the 2. This 1 by 2, 1 by 2, it will get cancelled out, and here we will be having 2. In order to remove the m, I am dividing the entire equation by the m, so because of that here we will be having our m. Okay, now it is basically 2gh plus k x square by m is equals to v square. Now what is the value of height we have? So as you can see, the value of height, that is gravitational potential energy above this point, this one is r by 2. I have already explained how this one is r by 2 and this one is r. So r plus r by 2, it will be 3r by 2. So 2 into g, h will be replaced by 3r by 2 plus k as it is. Extension we have already written, it is equal to r, so k r square by m equals to v square. Now this 2 will get cancelled out, so final value of v will be 3 g plus k r square by m inside the under root. So let's check the options, like 3rg, yes 3rg, kr square by m, kr square by m. So option number 4 will be our correct answer. So once again I'm explaining, the only thing which we have to understand in this question is to diagram. Once we have drawn the diagram, there is nothing which is basically tough in this question. Okay,